Another thing that we can do with this whole concept is we can calculate the solubility, or X, as it was in chapter 13, using the equilibrium constant and the equilibrium constant expression, just like we did in chapter 13. So we're going to use an ICE table. So let's go ahead and write that down so we can also calculate the solubility. And you're going to see sometimes it'll be called S, and but really that's just the same thing as X. You'll see it both ways because I think it's in the process of changing. But whenever you see S, just know that it's X, using a process just like what we used in chapter 13. And the reason why I'm saying it that way is that I want you to draw the connection that this is just chapter 13 material applied to a heterogeneous system, okay? And we give it a special name, solubility product, but it's basically the same exact thing. So let's look at an example here. So the KSP of copper 1 bromide, and that's going to be, there's the formula for it, is 6.3 times 10 to the negative 9. So what we want to do is calculate the molar solubility so that's going to be S or X, okay, of copper bromide. Okay, so the way that we start these problems is we go to our compound that we have in solution, and what we're going to do is write out the chemical equation, so that equilibrium for it. So here's copper bromide, and it's going to be in equilibrium with copper cations and bromide anions. Both of them have a coefficient of 1, so we can go ahead and write out the KSP, which actually I think I'm going to move that. Let's write out the KSP, or the solubility product constant expression, and that's going to be this right here. Okay, so now what we're going to do is basically just do an ICE table, okay? And so we have KSP. We don't have any other information. So in chapter 13, we would have perhaps had a concentration for one of the products, or a reactant or something. And in this case, all we have is KSP. But it actually turns out that we don't need anything else. So let's look at why. So let's do an ICE table. I'm going to write that over here. Do an ICE table. And I'll do that right here. So there's initial, the change, and the equilibrium. So the thing to point out first, this is a heterogeneous equilibrium. The solid that is present does not affect the equilibrium at all. Also notice that we were not given an amount of solid in solute that is in this system. So we don't know the amount of solid that's sitting at the bottom of the container. So guess what? We get to ignore this entire part, okay? We don't need it. It doesn't affect the equilibrium. So what we're going to do is pretend like we just barely put the copper bromide in the solution. And when we do that, initially we're going to have 0 concentration, none, okay? And then we're going to go to the change line, and some of the solid that we just put in is going to dissolve. Okay, now I'm going to go to a different color here and just put in plus S, because in case you see that, it's just the same thing. Okay, and then when we do our equilibrium, we're going to add them together just like we did, and we're going to get just plain old X or just plain old S. Okay, so now what we're going to do is plug that into our KSP expression. So KSP is equal to X times X. And that's equal to just plain old X squared. Okay. So let's set the whole thing equal 6.3 times 10 to the negative 9. Let's put in the value is equal to X squared. So X is going to be equal to the square root of 6.3 times 10 to the negative 9. And the value for that is 8.0 times 10 to the negative 5 molar. And that's the molar solubility. Okay. So again, just to really stress this, this could be just like this. So it's exactly the same thing if we call it S or if we call it X. Okay. So let me just make a note here. Notice that the solid is not involved in the equilibrium. We can ignore it. So it actually turns out that these solubility problems are actually the easiest thing that we do out of chapter 13, 14, and 15.